another class. Here we have a question on the board, and it's a differential equation, and we're asked to find the gradient of the curve y is equal to 15 over x squared minus 2x at a point where x is 5. So at the point on the curve where x is 5, what's the gradient of that curve? That's just what this question is asking us to find. But before we do that, we need to first of all find the gradient of the curve first. And how do we do that? We do that by differentiating y. So first of all, we are going to start by finding the y dx. So we have the y over the x. Recall that our y is giving us 15 over x squared minus 2x. Therefore, if we are to find the y over the x, that we are differentiating y with respect to x, this is going to give us, we're going to find that differentiating y 15 over x squared minus 2x. So looking at the rules of differentiation, we can use the quotient rule to differentiate this, or better still, we can still use the scalar multiple rule. Using the scalar multiple rule, but we need to first of all transform this function before we can use the scalar multiple rule. So we don't want to go through all that process. It's a very long process. So we can use the quotient rule. Because why am I using the quotient rule? This is a function whereby the two variables are dividing each other. So we have 15, which we can call our u. And then we have a v, which is x squared minus 2x. So recalling what the quotient rule states, it states that if we have quotient rule, states that v du over dx minus u the v over the x divided by v squared. Recall this is the quotient rule. And in this case, we know what our v is, we know what our u is, but we don't know what our du dx and v dx is. So pretty simple, we just need to find du over the x. That is, we need to differentiate u with respect to x, and we need to differentiate v with respect to x. So this gives us that our du over the x, it's when we differentiate 15, we have 0. Whenever you differentiate a constant, you have 0. And also we have that this is du. And then the v over dx, that is, we should differentiate v with respect to x. So to differentiate v with respect to x, the approach to differentiate this is using the addition, subtraction, differential rule. So that is to say, we're going to have 2x minus 2. So when you differentiate x squared, you have, using the power function rule that states that n to the x to the power of n minus 1. But x to the power of n is equal to nx n minus 1. So if I have x to the power of 2, it simply means 2x 2 minus 1. That gives me 2x, 2 minus 1 is 1. So that gives me 2x. All right, so then when we differentiate 2x, still using the power function rule, differentiate 2x, you're just going to have 2. So that's how we arrived at 2x minus 2 as the value if we differentiate v. So now we have the value of u, we have the value of v, we have the value of the v over the x, and we have the value of du over the x. So we just plug it into, we can call this equation 1. We just plug it into equation 1. So equation 1 says that if I have d over the x, u over v. What's our v? Our v is from equation 1. We're just plugging the values into equation 1. So our v is x squared minus 2x multiplied by what's our du over the x? Our du over the x is 0. So that's multiplied by 0. Still from equation 1 minus what's our u? The value of our u is 15. Multiplied by what's the value of the v over the x? That's 2x minus 2 divided by v squared. And what's our v? Our v is x squared minus 2x all to the power of 2. You can call this equation 2. Okay, just simplifying equation 2, we have that 0 multiplied all of these. Whenever you multiply any number by 0, it turns to 0. So we have 0 minus 15 minus 15 multiplied by 2x. That's going to give me, this is going to be 30x. And then minus 15 multiplied by minus 2, it's going to give us positive 30. So we have, so this is going to be divided by x squared minus 2x to the power of 2. This is going to give us minus 30x plus 30 divided by x squared minus 2x to the power of 2. Okay, recall the equation. The question says that we should find the gradient of the curve y is equal to 15 over x squared minus 2x at the point where x is equal to 5. So this is now, we've finally found the, finally differentiated that function and arrived at this. So now at the point where x is equal to 5, it means we just substitute the value of 5. Anywhere we see x, we put the value of 5. So we say at the point where x is equal to 5, we just substitute the value of 5. We can call this equation 3. I just substitute the value of 5, value of x, which is equal to 5, into equation 3. So if I substitute that into equation 3, I'm going to have, anywhere I see x, I just substitute 5 into it. So let's go, we have minus 30 into 5 plus 30 divided by, I have 5 squared minus 2 into 5 all squared. Okay, so 30 multiplied by minus 30 multiplied by 5 is going to give us minus 150 plus 30 divided by 5 to the power of 2. That's 5 times 5. That's giving us 25 minus 5. 2 times 5 is 10 all to the power of 2. If we proceed further, it's going to give us minus 150 plus 30 divided by 25 minus 10 is going to give us, that's 15 all squared. So 1 minus 150 plus 30 is going to give us minus 120 over 15 squared is going to, that's 15 times 15 is going to give us 225. So this is going to give us 225. And of course, we can just break this down, simplify this further. Can use 5 to simplify this. If I use 5, can go into 120, that's going to give me 24. And 5, I can use 5 to go into 225, that's going to give me 45. Okay, I can still simplify this further. I can say I can use 3 to divide 24, and that's going to give me 8. And 3 can also divide 45, that's going to give me 15. So what I have left is negative 8 over 15. So this becomes the gradient of the curve at y is equal to 15 over x squared minus 2x at the point where x is equal to 5. All right, I believe that was pretty simple and straightforward. Let's move on to a second question, a similar question, just so that you can have more questions to understand what we're doing. Okay, if we have that we should question that says you should find gradient of the curve this is a similar question saying you should find the gradient of the curve y is equal to 8 over 4x minus 5. So remember when we're solving the first question, I told you you could use also the scalar multiple function to get the answer. But in our first example, we use the quotient rule. So in this example, I love to use both so that I can also show you how you can use the scalar multiple function to solve questions like this. So I'm going to use two methods to solve this question. One is going to be the scalar multiple function method, or what we call the scalar multiple rule, rather than we are also going to use the quotient rule. And we are going to arrive at the same answer, irrespective of the method we use. But let's start with the scalar multiple rule. And using the scalar multiple rule to solve this, I'm going to incorporate chain rule. I'm going to incorporate chain rule in solving this question. Okay, so we have that y is equal to 8 over 4x minus 5. We can transform this um, equation to also say that y is equal to 8 multiplied by 4x minus 5 to the power of negative 1. Okay, before I even go there, I need to still break it down so that I want you to really understand what I'm doing. So you agree with me that this is the same thing as saying 8 multiplied by 1 over 4x minus 5. Because 8 multiplied by 1 will still give us 8. And we have the denominator as 4x minus 5. So this is the same thing as saying 8 multiplied by 4x minus 5 to the power of negative 1. Recall the laws of indices where if you have the value of laws of indices, you have 1 over a is equal to a raised to the power of negative 1. Law of indices. And if you have same vein, if you have 1 over a square, is the same thing as saying a to the power of negative 2. If you have 1 over a cube, it's equal to a to the power of negative 3. This is just laws of indices. So that's just what I applied here by saying 1 over 4x minus 5 is the same thing as saying 4x minus 5 to the power of negative 1. So I've been able to transform this. Y is equal to 8 into 4x minus 5 negative 1. So looking at this now, I can use the chain rule to differentiate this equation. So if I use the chain rule to differentiate, this means I'm going to differentiate the inner function and also the outer function. So if you don't understand chain rule, I have a class, a tutorial where I explained chain rules. I explained 7 rules. Sorry, I explained the rules of differentiation. Chain rule was one of them. I explained the 7 rules: the power function rule, the scalar multiple function, the quotient rule, product rule, logarithmic rule, and I also explained the addition and subtraction rule. I explained it vividly with examples, so you can go watch that video to get a better understanding of the rules of differentiation. Because if you don't understand the rules of differentiation, questions like this will look messy to you. It will look difficult to you. So you need to start with the basis, start with the laws, understand the principles, understand how these laws can be applied in questions. That's the first step to getting this right. Okay, so if I use the chain rule to solve this, what am I going to do? I'm going to differentiate the inner function. I'm also going to differentiate the outer function. So if I differentiate these, what I have is I'm going to have that y. So if I differentiate the y over the x, this is saying I should differentiate this 8 into 4x minus 5 to the power of negative 1. And if I differentiate that, this is going to give me, first of all, let me differentiate. Okay, so this is going to be, I'm going to bring out the constant, which is same thing as saying 8, which is the constant there, and I'm going to differentiate 4x minus 5 to the power of negative 1. If I differentiate that, I'm going to have, using the chain rule, this is what I'm going to get. This is going to be 8, which is a constant, multiplied by, now I'm going to differentiate this. I'm going to have negative 1 multiplied by 4x minus 5 all to the power of negative 1 minus 1 into, if I differentiate 4x, I'm going to have 4. So this is going to give me 8 multiplied by negative, have a negative number there, and this is going to give me 4x minus 5 to the power of negative 2 multiplied by 4. Also, again, I'm going to bring out, I can see another constant here, 4. So this can be 8 multiplied by 4 into negative 4x minus 5 to the power of negative 2. And 8 multiply, if I have 8 and I have to the power, 8 multiplied by 4 to the power of negative 2. So I'm going to say if I have 8 multiplied by 4 to the power of negative 2, first of all, this is going to give me 32, negative 32, 4x minus 5 to the power of negative 2. All right, so this becomes the becomes the value one would differentiate the function y is equal to 8 over 4x over 5. Well, we can still rewrite this equation to be negative 32 divided by 4x minus 5 to the power of 2. Still the law of indices, you remember? So this becomes, this is the same thing as saying negative 32 multiplied by 1 over x minus 5 to the power of 2. So because of this negative sign, that's why I'm having 1 divided by an all to the power of 2. So from this, we can arrive at this. Pretty simple. But we are not done. The question says we should find the gradient, find the gradient of the curve at the point x equal to 2. So where x equal to 2, the point where x is equal to 2, I can call this equation, well, I didn't number my equations. Since I didn't number them, let me call this equation 1. Okay, so from equation 1, that x is equal to 2. This is to say, wherever we find x, we should substitute the value of 2 into that equation. So at that point, I'm going to have, anywhere I see x, I put 2. So from equation 1, what I have is negative 32 divided by 4x. So wherever I see x now, I'm putting 2, and then 5 to the power of 2. What this gives me is negative 32. 4 times 2 is 8, minus 5 to the power of 2. This is the same thing as saying negative 32. 8 minus 5, that's 3, all to the power of 2. And then we have, this is going to give us negative 32 divided by 3 to the power of 2 is 3 times 3, and that's 9. And this becomes our final answer to the question that says we should differentiate. We should find the gradient of the curve y is equal to 8 over 4x minus 5 at the point x is equal to 2. Well, we can still break this down if we want to break it down. Since this is an improper fraction, we can still take it down to a proper fraction. So if we break that down, we're going to have minus 3 whole number, and that's 5 over 9. Right, so recall this. This is our answer. This is using the scalar multiple rule where I, used the chain rule and also use the power function rule inside of it to get this. Now I'm going to use the quotient rule. We're going to still arrive at the same answer if I use the quotient rule. So let's put this as our answer, and we are going to come back to that. So now let's use the quotient rule. We're going to find out that it's still going to give us the same thing. The idea is if you just know how to manipulate these things to suit what these rules, the equation of this rule looks like, then you can use the rule. So why I was able to use this chain rule is because I was able to manipulate x over 4x minus 5 to suit what the chain rule says. So also to this equation, y, still what we're looking for, is equal to 8 over 4x minus 5. This already looks like what the quotient rule states, because the quotient rule is saying that when the functions are dividing each other, use the quotient rule. So here you can see 8, and this dividing 4x minus 5. So the quotient rule can also play a part in solving this equation. So using the quotient rule, what does the quotient rule state? The quotient rule states that if you have two functions dividing each other, what you need to do is you should use this by saying dy over dx. Sorry, that's going to be du over v equal to, for the quotient rule, this is what it states. You have v du over dx minus u, and you have dv over dx divided by v squared. Let's call this equation 1. That's what our quotient rule. This is a standard formula for what the quotient rule states. So if we want to incorporate this from this equation, y is equal to 8 over 4x minus 5, we now have that our u, this is the value of our u, this is the value of our v. So u is equal to 8, therefore du over the x, that's when we differentiate u with respect to x, we have 0. Because whenever you differentiate a constant, you have 0. And then in the same vein, we have our v is equal to, what's our v? 4x minus 5. Therefore, differentiating the v over the x, it's going to give us 4 minus 0, which is equal to 4. When you differentiate 4x, you have 4. And then when you differentiate a constant 5, you have 0. So 4 minus 0 is 4. So now let's plug it into equation 1. We can now say from equation 1, we just need to substitute all the values we found here into equation 1. So if we do that from equation 1, we're going to have u over v. So from equation 1, our v is 4x minus 5. So I'm going to say 4x minus 5. Our du over the x is 0, minus our u is 8. Now the v dx is 4. This is all divided by our v square. Know what our v square is? Our v, first of all, our v is 4x minus 5 all squared. Now, anything multiplied by 0 is 0. So 4x minus 5 multiplied by 0, this becomes 0. Minus 8 multiplied by 4, that's 32. Divided by, we have 4x minus 5 all squared. And that's going to give us minus 32 divided by 4x minus 5 all squared. So you can see that what we arrived at before from using the chain rule, you could see it, that we had the same thing here. And then when we used the also see we arrived at the same using the quotient rule. We arrive at the same value. So irrespective of what you use, as long as you do the right thing, you arrive at the same. So this is negative 32 over 4x minus 5. And using the quotient rule, we still arrive at negative 32 4x minus 5. So what we just need to do here is to substitute. So we just need to substitute the value of x is equal to 2. So at x is equal to 2, we have that negative 32. By substituting into this of this value over there, so we're going to have minus 32 over 4 into 2 minus 5 all squared. And this is negative 32 divided by 8 minus 5 all squared. And this is negative 32 divided by 8 minus 5 is 3 all squared. And that's going to give you negative 32 divided by 9, which is the same thing as saying 3, 5, over 9. So at the point x is equal to 2, the gradient of the curve y is equal to 8 over 4x minus 5 is giving us negative 32 over 9, or in an improper, in the mixed fraction form, negative 3, 5 over 9. So that's how you solve questions like this. First of all, you need to differentiate function and then substitute the value of x into whatever you differentiated, and that gives you the final answer. So you can go through this, whichever method suits you. So let me know which one was easier. Was it using the chain rule or using the quotient rule? Because when we used the both of them, we still arrived at the same answer. So for you, which one was simpler? Which one was easier to understand? Which one are you going to use? Do you prefer the chain rule or you're going to use the quotient rule? Just let me know. You can just write it down in the chat box. Just write it down. Let me know which one you prefer to use. To me, I prefer using the quotient rule because it's pretty straightforward, pretty easy. Sometimes you might have complex functions where if you're not extremely careful and excellent, you might miss it out when differentiating using the chain rule.